Hey there. Welcome, all my everyday statistics peeps. How you guys doing today? I'm excited to do our first lesson of the year. Just kind of an intro into some vocabulary for the course and just looking at different types of graphs and things like that that we might use. All right. So we'll just be looking at one variable data. Let's go ahead and have a look. All right, so today during this lesson, we're going to do these things. We're going to talk about the different uh, ways that we can name things in a data set. And then we're also going to create a frequency table and a relative frequency table. All right, so statistics is really the math of science. It's going to be how we're going to analyze data created in either a setting that's an experiment, or maybe it's a setting where we're just observing things that are going on in our environment. So we have our definition of statistics there. All right, so in this process, we got to ask a question. Then, depending on what that question is, we're going to collect data in some sort of way. We're talking about all the different ways that we collect data. We'll learn how to analyze data, and then we'll interpret the results using some sort of statistical analysis, some sort of tool that we're going to learn in here. A lot of times we're going to be looking at data that's going to be arranged like this in a chart, um, some sort of table. And in order to really get into this table, we need to talk about all the different pieces of it, right? So we've got variables and we've got some individuals. In this case, we're looking at, it looks like, some roller coasters. We've got their names over here on the far left, right? We've got some names. Those are all the individuals that are in this data. Our individuals in this case happen to be some roller coasters. And then we've got some variables in there, right? Looks like we have what? We've got 1, 2, 3, 4, 5 different variables. The variables that have been chosen are the type. We got height, design, speed, and duration, right? How long is this roller coaster? I like this one. I like a nice long roller coaster. All right, so there we go. So there's our formal definitions. I kind of used them in context of this table. We've got our individuals and variable definitions there. Move on to the next one here. So our variables can take on different values. We need to know the difference between, it's actually extremely important to know the difference between a categorical or a quantitative variable. All right, a categorical variable is going to be something like, what's your favorite color, right? You can't answer that with some sort of a number. You can only answer something like blue or green. What's your favorite car? 10. It doesn't work, right? You're going to answer the name of a car. And the problem with that is with data that's like that, right? I can't find an average. I can't find a standard deviation, something we're going to learn about here in a little bit. There's actually not a lot of information that I can get. But if I can turn that information into a quantitative variable, then I get a number value for it, right? So how many people chose green as their favorite color? Then, rather than having some data that's not useful, now I've got 5 people on average said they liked the color green, something like that. So that's the difference between a categorical and a quantitative variable there. And I must have somehow repeated the slide. All right, so as I was saying, right, all of these are categorical variables here where we're talking about. Now remember, roller coaster was not a variable. These were our individuals. And each one of these individuals have different variables, type, height, design, speed, duration. Obviously, type is not a number quantity. We can't take an average of it. Would it make sense to add or subtract numbers to that? And the same with our design as well. And our quantitative variables obviously are the ones that are numbers. Now be careful, right? Not all data that is numerical is a quantitative variable. For instance, a zip code is not a quantitative variable. A phone number, not a quantitative variable. Social security numbers, things like that, right? It wouldn't make sense to take the average social security number. It wouldn't make sense to look at the average of zip codes. It would mean nothing. It would be nonsense. So just be careful with that. Not all numbers, not all data that is numerical is quantitative. All right, so these variables can change depending on individuals. For instance, if the variable that we were choosing was height, right? You'll find out fairly shortly that I am also fairly shortly. So I'm kind of a short guy, definitely below average height. So if our variable that we were looking at was height, right? My height is going to be different from your height, probably, as that's going to be different from another height, right? The heights of each individual vary. And the distribution of those individual heights, right? If we gather all of the data on the heights of people in our class, right, we're going to get a bunch of data that's kind of all over the place, right? We're all different sizes. And what we're going to be looking at when we look at that all that data is it's going to be called a distribution. So the way that we can arrange all of that data is that data's distribution. All right, all the different values that that variable can take on. We're going to be able to summarize this with a relative frequency table. First of all, let's talk about our frequency table, which they don't have up there at the top. But a frequency table is just going to give us count. So we're going to make each of these things here before the end of the lesson. We'll make both a frequency table, and then we're going to use the data from our frequency table to show a relative frequency table. A relative frequency table is going to tell us what percent of individuals are below that, or what proportion have a particular value. So, for instance, I am probably somewhere in the total guess, but probably somewhere in the 30 to 40th percentile for male heights in the United States. What does that mean? That means that I'm taller than 30 or 40% of males in the United States, but it also means that I'm shorter than the rest. So that's how we'll look at that relative frequency. All right, so this is where we're going to begin working with some data and making, first of all, answering some questions about this data set. And then the next thing that we'll do is we'll actually construct a frequency plot and a relative frequency plot. All right, so the first thing we're doing with this is, let's look at the question. We need to identify the individuals and variables in this data set, and we're going to classify each variable as categorical and or quantitative. So first of all, what are our individuals in this data set? Well, let's see. The instructor gave 40 students in the class a survey. So, what are our individuals? Well, it looks like our individuals, wrong pen here. Our individuals are the students. I can spell, I promise. Individuals. All right. Um, that is the students, right? Because we looked at 40 students, right? We got the first 10 students on the class roster. So each one of these things, right? For instance, we don't know their names. So, if these individuals are students, we'd say, we got student 1, student 2, 3, 4, 5, and so on, right? So these students are individuals, but all of this stuff up here, these are our variables, right? So each student has all these different variables, right? They're different genders, they are in different classes, they have different GPAs. Good grief, their pulse rate's different. Uh, this person, and it's really nice to actually look at data and interpret it as you look at it, right? I looked at pulse rate. I saw this guy has a pulse rate of 144. He probably just climbed up those stairs. So that's an unusual specific data point. And I don't know, just as I'm looking at data, I like to notice things like that. I think it's very good. Anyways, we've got dominant hand, children in the family, sleep hours, and do you have a smartphone? We've been asked to classify these variables as either categorical or quantitative. So gender here, what do you think? I'm going to mark it as a C. It is categorical, right? Class, categorical. I could not get an average on that. It would be strange. Maybe if I arrange class by, freshman being 1, sophomore being 2, and so on, maybe I could get an average, but it still wouldn't make sense, right? What's the average grade? 2.4. So on average, a student is halfway through their sophomore year. That's just kind of weird. So that is categorical. Now we could find an average GPA, right? So that's going to be quantitative. Our pulse rate, also we could find an average pulse rate. And I think you've noticed that one of the ways that I classify data as either categorical or quantitative is I think to myself, does it make sense to take an average? If it doesn't, then it's going to be categorical for most cases. So this one's categorical, average hand. Children and family, yeah, it would make sense to find the average number of children in a family. Homework last night in minutes. So, I mean, what's weird about that is that it's an interval, right? So how do we know? Could we find an average for these intervals? I think we could. It would be strange though, because we'd have to find like an average interval. So the homework last night is strange because, well, you could find like an average duration. Because they're intervals, it's going to be strange. We're going to need to organize in a different way. We couldn't find an average with the data as it is. So this one is categorical. Sleep, quantitative, and have a smartphone is categorical. All right, so the next thing we're going to do is look at this data and create or our age data. Did we not have this age data here? No. So we got some extra data. We got the ages of these 40 students in the class, all right? And we're going to go ahead and summarize this distribution with a frequency table and then a relative frequency table. So let's go ahead and start with our frequency table. All right. So we're going to have age, and we're going to have frequency. how often does that particular age show up? And it's going to be nice to arrange this, I think, from least to greatest or from greatest to least. But as long as the data either ascends or descends, it's going to be much nicer to look at. So I'm going to go ahead and make it ascending. So we're going to go from smallest to greatest. So what is the smallest number that we have up here? Yes, that's right. It looks like 14. So I've got a 14 here. I'm going to have to count how many 14s. And actually, let's just look through it again and just make sure. It's really nice when I have students in the room because they can catch me if I'm slipping. But it looks like 14 is the lowest one. So let's count how many of those we have. First of all, 14-year-olds, right? That's one of our, so our individuals in this case are students, right? And one of our variables is age. So we're looking at the variable of age. We're going to make a frequency table for age and a relative frequency table for age of these students. So how many 14-year-olds do we have, right? How frequently do we encounter the data point 14 in this data set? Well, there's 1, 2, 3, 4, 5. Is that all of them? Just going to make sure. And so that's my frequency. There are 5 14-year-olds. Move on to 15. How many 15-year-olds? 1, 2, 3, 4. All right, we'll put 4 there. Moving a little more quickly. 16-year-olds. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 16-year-olds. 17-year-olds in the class. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17-year-olds. What a coincidence. And last but not least, how many 18-year-olds are in the class? Let's count them up. There are 1, 2, 3, 4, 5. Very nice that I crossed them all out, because if I finish this and I notice that one of the numbers is not crossed out, then I did not include it in my frequency table. So there it is. I have made a frequency table. It tells me how frequently each age occurs. And now this data looks so much better, makes more sense. It is much more organized. So let's go ahead now and make our relative frequency table. And I'm just going to put table down here. Here we go. All right. So now we're going to have age, and we're going to have a relative frequency instead of our frequency. So here, now we'll still have age here. And then over here, we're going to have our relative frequency, if I could spell. Relative. And I'm going to go ahead and abbreviate frequency. I'm going to scroll this up a little bit, because really at this point in time, I'm going to be using this, my frequency table, in order to get a relative frequency. And the first thing that I'm going to need to do is I need to add up these values in my frequency table. Well, they should add up to 40, right? Since they're 40 students numbers, right? So now I'm going to find what percentage of all the students, for instance, 14-year-olds make up, right? So there are 5 14-year-olds. So what percentage of the total is that? Well, how do I find that out? Well, I divide 5 by 40, and that's going to give us a decimal. We'll turn that thing into a percentage. So I get that 5/40 is 0.125, which is the same thing as 12.5%. And really, this is the number we're looking for, right? We're looking for what percent of the total that is. All right, so we know that 12.5% of the students in this class are 14. Our 15-year-olds, we have 4 divided by 40, all right, or 0.1, which is going to give me 10%, right? Okay, 16-year-olds, go through the same process. We've got 9 out of 40 of them, which is going to be 0.225. And again, what I'm doing is just putting in my calculator 9 divided by 40. Okay, 9 divided by 40, it outputs this. And then we go ahead and we turn that value into a decimal. How about 17-year-olds? 17 out of 40. And then when we actually divide that, we wind up with 0.425 or 42.5%. And then lastly, we've got some 18-year-olds in the class, and there are 5 of them. If we look above, we don't have to enter this in the calculator again, right? It was the same amount that were 15-year-olds. All right, that should all add up to 100%, by the way. You can check it. It ought to work. And there you go. We've done it. So we've made a frequency table and a relative frequency table today. Awesome. Awesome. All right. So today we learned some vocabulary. All right. We were able to look at a data set, identify individuals, variables, and then just what we did just now, we made a frequency table and a relative frequency table. So now we're going to turn you loose on some of this and have you do some of the same things. Thanks for watching, and I hope that the rest of your day is just amazing. See you later.